So let's have some fun and create a traffic light. We're going to create a software-controlled traffic light over hardware LEDs. And this is what the flow looks like. I've got a red switch, and that's this switch icon here. Let me show you how I've configured it. When you click it to the on state, it sends a true level. If you click it to the off state, it then sends a false level. I've done the same thing with the green and the blue switches on my software dashboard, which is right here. See my software dashboard with my 3 switches. And the outputs here are going to the red LED on port 12, going to the yellow LED on port 20, and then going to the green LED on port 21. And that's how I wired it. So if we take a closer look at the camera view, you'll see that I've got my 3 wires from port 12, 20, and 21 going into 3 individual resistors to control the current into a red, green, and yellow LED. Red, yellow, green, just like a traffic light. So let's go back here to our Node-RED dashboard with our inset. And let's go up here to our dashboard and let's watch the red LED. And lo and behold, I just turned the red LED on and off, the yellow LED on and off, and the green LED on and off. And now I have software control over a traffic light. Pretty cool, huh? So now that we've shown you how to turn on and off individual red, green, and blue LEDs, let's have a little fun and combine those into a single LED. So here we have a triple LED where it's a single housing with a red, green, and blue LED in there, all combined. And what this looks like is basically you have 4 leads. You have a common lead, which is the long one. Then you have the red lead, green, and the blue lead. Now, this particular device is what's called common cathode. So the common lead that's hooked up to the cathode of each of the 3 LEDs are tied together inside, and you connect that to ground. And then to activate the LED, you have to give it a voltage level, a high or a 1, on each of the respective pins, the red, green, or blue pin. Now, if this were a common anode LED, then I'd have to do the opposite. I'd have to give voltage to the common pin, and I'd have to pull the red, green, or blue leads to ground, or 0 or false, to be able to activate the LED. And that's called an active low type circuit versus an active high circuit, to activate it on a high signal versus activate it on a low signal. So we've hooked up this LED in the same fashion that we did with the individual LEDs, but we've connected the common cathode to ground, and we have our 3 current limiting resistors in here in line. So let's now switch back to the dual mode, and you can see what we've got here now is the same connection as we had before with the individual LEDs, but they're just wired all together. And to show you that, you can see I'm turning on and off the red, turn on and off the green, and turn on and off the blue. So that's individual control of a red, green, and blue combination triple LED. So now let's take a look at pulse width modulation. We saw before that we can control the digital output of a GPIO pin with digital. We also, along the way, we'll see how we can bring in signals from analog signals and measure them digitally. But now we're going to output a digital signal whose output is proportional to an input value. And this is how this works. We start off with a clock signal, and very often in code, Node-RED code, we have 100 Hertz on the PWM. That is the basic signal. So there's a clock with a 50% duty cycle or duty factor. It's on half the time, 50% of the time, and off 50% of the time, as you can see. That's our baseline. Now what PWM does is it allows us to put a digital input into that PWM input to a GPIO pin and determine what fraction of the time you really want the on time to be versus the off time. And that's called the duty factor. And here it's a 25% duty factor because it's on 1/4 of the time of the cycle. Here it's a 50% duty factor because it's on half of the cycle, as we can see, matches the clock. 75% is it's on 75% of the time. And depending on the number of positions that I have, could be, in this case, 4 positions, 0, 25%, 50%, 75%, 100%, 5 positions actually. You could have 100 positions where it could be a percent, 1%, 2%, 3%. And then you'll see if it's 1% or 2%, this would be a very small. And that means the on time is very short and the rest of the time is off, which can be used for things that can heat up. You can give a lot of power for a short period of time, then let it cool down, do it again. Or you can give it more power for a period of time, and you can turn it on all the way and have it on constantly, in which case it's just on, 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 on. So that's how pulse width modulation works. So next we're going to do an example of a pulse width modulation controlled triple LED, the same triple LED we used in binary control. But we're going to use the slider for controlling it. So we've set up the slider to go from a range of 0 to 10 in steps of 1 for each of the drive, red, green, and blue, and it's only going to update upon release. And we're going to send that into the input of the triple LED. Well, we're going to use PWM output, and if you recall, PWM, it oscillates back and forth between a 1 and a 0 state, and how long it spends at the 1 state versus the 0 state is what we're going to control with the slider. And the larger the slider number, the longer it stays at the 1 state, from 0 to 100%. And so with that, let's take a look at our triple LED as we go to our dashboard and control the red slider. So let's control the red slider, and we can see that we bring up the red. I'm going to turn it all the way up. Now you may not see the full color in the video because the video camera will saturate. Let's try the blue. Okay, so now it's very blue, it's less blue, very little blue, light blue. And here we've got green. I can control the green independently. And what's really cool is I can then combine the red and the blue to create kind of a magenta. And so for you to see it, let me turn it way down to like a level 2 and level 2. And when you try this on your own, you'll actually see the colors come out very nicely. And I can create any combination of colors I want. Red, green, blue, yellow, orange, magenta, cyan. If I give it a green and a blue, then I've got a nice cyan color, which is kind of like a turquoise, aquamarine kind of a color. So if you get to play with this, then you'll see that you have total control proportionately by using the pulse width modulation to change the proportion of on time versus off time of an alternating 1 and 0 output. And we can see what that output is based on a frequency of 100 hertz. In other words, it goes back and forth 100 times per second, and the input signal changes the amount of on time versus off time. So that's that experiment.